Malaria is transmitted by mosquitoes. Falciparum malaria has probably killed close to 500,000 people in the last time the statistics were recorded on the subject. That basically makes it the deadliest parasitic disease known to mankind.
So on the morning ward round, half of these babies are low birth weight. If it can get through the first year of life, then as it grows up as an adult, it's much more susceptible to cardiovascular disease, diabetes, hypertension. So it's not just pregnancy, it's a lifelong effect from this infection in pregnancy. So we really need any tool we can to reduce malaria in the community.
In 2016, we had 1,600 cases approximately of malaria in the United Kingdom. All of them were imported, none of them were acquired in Britain. So it's a real problem for our travellers, but predominantly in the tropics it's the poor people that bear the brunt of this disease.
Right now what is happening with certain ACTs within the region in Southeast Asia is that 60, 70, 80% of the people actually don't get cured after they're treated. But if you can imagine that, those kinds of parasites with those mutations end up getting to Africa where there's hundreds of millions of cases, and then 60, 70, 80% of those people cannot be treated with the drugs that are being used, then it is a catastrophe basically. When you're doing an in vivo trial to assess whether or not an antimalarial treatment is working and it's actually killing the parasites, first you will do microscopy to confirm that the person actually has malaria. Then you treat them, and then you follow them up over anywhere from 7 to 10 weeks actually. Each time the person comes back for a follow-up visit, you have to do microscopy again. But the microscopy itself is actually quite hard. In the blood, you will see many different forms of the parasite. Each of the species is slightly different. So being able to identify a parasite, number one, but also being able to identify which species it is and which form of the parasite it is, it actually takes a lot of training and a lot of experience.
When we had 100 patients per day at this clinic, 100 falciparum patients per day at this clinic, the microscopists were exhausted.
Studies have shown that as people look at more and more slides of malaria, their performance drops over time. So the goal of the EasyScan Go is to match the performance of a human microscopist when they're looking at the slides. So to do that, we have to use something called computer vision, where you try to train computers to see images in the same way that humans do. So the way we do that is with methods called machine learning methods, specifically deep learning methods, which are one of the cornerstones of artificial intelligence. To develop the algorithm, we had to collect a database of thousands of slides. We could then use that big cache of data to train our algorithms on how to find the malaria parasites.
We set up Motic Optical in China in 1988. Motic has become biggest microscope manufacturers in mainland China and #1 brand name in industry in China.
So we had the conversation with Global Good and decided that maybe we should do what we do best at Motic, which is develop high-quality instrumentation and partner with the Global Good group, who really does software well.
So a technician would have to go through a big box of slides like this over the course of a few days. And when that's ready to go, it's inserted into the EasyScan Go hardware. The EasyScan Go software produces a report that shows you a variety of things about the blood sample. It will tell you whether the person has malaria, the species, the estimated parasite count. So this is the data that the user would use to make a definitive diagnosis of malaria. Currently, the problem is that researchers aren't able to compare results from different times and places in the world. So for example, in Peru in 2017 versus Thailand in 2015, they'll have different parasite counts and different misdiagnoses that make those results not comparable.
I could see it having a place in a general hospital where malaria is not commonly seen. In this situation, the possibility to deploy advanced technology and make a precise malarial diagnosis is an exciting one if it matches up.
This technology will help in a few ways. In the global fight against malaria, the EasyScan Go will allow researchers from around the world to collect accurate, consistent results that will allow people to track a disease that's very dynamic and mutating and changing. Long term, our goal with the EasyScan Go is to put quality diagnosis of a variety of diseases within reach of family.